In the diagram below, P is the midpoint of side WQ of triangle WQR. V is on WR such that VP is parallel to RQ. PV is produced by its own length to S. PW is produced to T and ST drawn. A, give a reason why WV is equal to VR. B, prove that 1. Triangle VWP is congruent to triangle VRS. 2. SWPR is a parallelogram. 3. PQRS is a parallelogram. And C, if it is further given that RSTW is a parallelogram, show that TQ is equal to 3SR. Let's start with part A. Give a reason why WV is equal to VR. Now, this question is not asking us to prove if WV is equal to VR. It is rather telling us that WV is equal to VR and asking us to give a reason why. The question tells us that P is the midpoint of side WQ, and it tells us that PV is produced by its own length to S. This means that V is the midpoint of SP. When we are given numerous midpoints, it is always a good idea to consider the midpoint theorem. WV and VR lie on WR, so let's make this line red. WV is equal to VR, so let's put a small blue line on WV and a small blue line on VR. We can see that in triangle WQR, P is the midpoint of WQ, and we can see it on our diagram over here. The question tells us that VP is parallel to RQ. So let's put a small blue arrow on VP and an arrow on RQ to show that they are parallel. Now we have P, the midpoint of WQ, and we know that VP is parallel to RQ. So the only way to prove that WV is equal to VR is to use the converse midpoint theorem. So this is our answer. Prove that triangle VWP is congruent to triangle VRS. On our diagram, let's make triangle VWP green and triangle VRS purple. Now we have quite a bit of information on our diagram, so let's start here. In part A of this question, we were told that VW is equal to VR. And we found the reason for this to be the converse midpoint theorem. So you can use this as the reason here again, or we can simply say proven above. In the diagram, we can see that VP is the same length as VS. So we can say VP is equal to VS because this information has been given to us. Now we need to find one more side or the included angle. We know that WP is the same length as PQ, but we don't have enough information to prove that SR is equal to either of these. So let's look for an angle. We have found two pairs of corresponding sides, so we need to find the included angle. In triangle VWP, we are working with sides VW and VP. So V1 is the included angle. Let's mark it in blue. In triangle VRS, we are working with VR and VS. So angle V3 is the included angle. Let's make it blue as well. Angle V1 and V3 lie vertically opposite each other. So we know that these angles are equal. So we can say angle V1 is equal to angle V3. And as our reason, we say vertically opposite angles. Now we have two pairs of corresponding sides and one pair of included angles. So we have now proven that triangle VWP is congruent to triangle VRS. And as our reason, we use SAS for side, angle, side. Prove that SWPR is a parallelogram. In the diagram, we don't have a line for SW or a line for PR, but please do not let this confuse or scare you. The question is asking us to prove that SWPR is a parallelogram. So to do this, we simply draw in the two missing sides. Let's draw in SW and PR in green. And now we can make the whole parallelogram green. To prove a parallelogram, we can prove that both pairs of opposite sides are equal, both pairs of opposite sides are parallel, both pairs of opposite angles are equal, the diagonals bisect, or one pair of opposite sides are equal and parallel. Before you attempt to prove any quadrilateral, it is always a good idea to look at the information you've been given, as this will tell you which proof to use and if there's anything else you need to find. Now, in this case, we drew in SW and RP, so we cannot tell if these sides are equal or parallel, which means we cannot use equal or parallel sides as possible proofs. We also don't have enough information about the interior angles. But we do know that SV is equal to VP, and we know that WV is equal to VR. So we know that the diagonals bisect each other, and we can use this to prove the parallelogram. So now we can say that SV is equal to VP. We know this because this has been given to us in the diagram. We also know that WV is equal to VR because we proved this in part A. So as our reason, we say proven above. Now we can see that the two diagonals bisect each other. So as our answer, we can say SWPR is a parallelogram. And as our reason, we simply say because the diagonals bisect. Prove that PQRS is a parallelogram. Let's make PQRS green. In PQRS, we don't have any diagonals and we don't have enough information about the interior angles, so we need to consider the sides. Remember that you can use your answer to part 1 of the question to help you solve the next part. We have just proven that SWPR is a parallelogram, so let's redraw this in red. Side SR sits in parallelogram SWPR, but it also sits in PQRS. We know that in a parallelogram, opposite sides are equal, so we can see that SW will be equal to WP. We have a small black line over here on WP, so let's put a small black line on SR to show that these are equal in length. We also know that opposite sides of a parallelogram are parallel. So SR is parallel to WP. So let's put two small blue arrows on SR and two arrows on WP to show that they are also parallel. Now we can take the red parallelogram out of the diagram. Now we can make some notes. We know that SR is equal to WP because the opposite sides of the parallelogram SWPR are equal in length. But in the diagram, we can also see that WP is the same length as PQ, which sits on PQRS. So we can say that WP is equal to PQ, and we know this because this has been given to us in the diagram. Now we can see that SR is equal to WP, and WP is also equal to PQ, which means that SR must also be equal to PQ. So now we know that one pair of opposite sides of PQRS are equal. But we still need to begin here. But we still even need to find that the other pair of opposite sides are equal. Or we need to prove that SR is also parallel to PQ. We know that SR is parallel to WP because the opposite sides of the parallelogram SWPR are parallel. But the question tells us that WQ is one side of triangle WQR. So this is a straight line. This means that if SR is parallel to WP, then SR will also be parallel to PQ. On our diagram, let's put two blue arrows on PQ. Now we can see that not only is SR equal to PQ, but both of these lines are parallel as well, which means that we've now proven that PQRS is a parallelogram. So as our answer, we say PQRS is a parallelogram because one pair of opposite sides are equal and parallel.